All right, so let's take a look at what we're doing here. We're going to look at the center shape and spread for our 6.5 notes. All right, so when we do that, we're going to determine the center is typically the median, could also be the mean or the mode. We're going to also look at the shape, whether it's symmetrical, left skewed or right skewed, and we'll talk about each of those. And then the spread is how the data is spread across the graph. So let's take a look at our shapes, and we're going to talk about them. A normal symmetrical shape, okay, looks like this guy. It's split down. Whoa, sorry. Okay, it is, if we have a peak, it's nice and even along the center. Okay, so what this does, and this is a normal distribution, and a normal distribution is symmetrical, meaning that each side is equal. Okay, but now we're going to talk about the tails. So this is the left tail because it's on the left side, and this is the right tail. They are typically equal, the same size in a symmetrical data set. However, we can have skewed data, which means that when it says left skewed, it means that our left tail is longer. So what that means is that we're going to go up and then come down. And now we see that this is the peak, okay? And then guess what? This is our left side tail is longer, which means that it is left skewed. Okay, we don't look at where the peak is, we look at the tail to determine skewedness. So this is a left skewed data. Let's talk about a right skewed data set. So that means that the right hand tail, the tail on the right, is longer. So we peak on this side and then we come down, and our tail on the right of our data set is longer. So here's our peak, and this side to the right is the longer side, so then we have right skewed. Okay, so when we're talking about skewedness, we're talking about the tail, not the peak. Okay, so this left tail is long, so that is left skewed. This right tail is long, so that is right skewed. So let's take a look at identifying some shapes. Okay, so here we have this one. We have our peak, and then we have this. So we're going to draw a line down from our peak down here. So the tail is on the right. So this is right skewed. All right, let's take a look at this one. We're going to kind of draw on our shape. It kind of goes like this. It peaks and then comes back down. So we draw a line down the middle. And our tail is longer on this side, on the left, so that this is left skewed. All right, and this one, here's our peak, draw a line down the middle, okay, and our tail is on the left-hand side, because again, the peak, there's a left and there's a right, so the longer tail is on the left, so it's left skewed. All right, and then in this data set, I'm going to draw our peak right there, come back down. All right, and it looks like the tails are about even, so we call this one symmetrical. And there we go. Moving on. What is the shape of this one? Well, here's our peak. Okay, we're going to come down here. We got this one, and then we have this one. So again, the longer side is on the left, so this is left skewed. All right, this one, it doesn't matter where you are on the graph. It only matters about the data. Okay, so if we look at our two tails, they are about the same, so we call that symmetrical. Okay, again, we only care about where our data is. I don't care that this side goes all the way over here. If there's no data over there, then we draw our center, because this side can go on forever and ever too. So again, these two tails are about the same, so we call that symmetrical. And we look at this one. We're going to draw our shape. And above all of our data points. And there's our center. So our tail is on the right. So we get a right skew. All right, and then this last one. We're going to look, and here we go. All right, so draw a line down the middle. Our longer tail is on the left, so this is left skewed. The spread of the data, it's really referring to the range, and then from the range we can interpret that into our standard deviation. So if we look at this first graph, it goes from about 1 to about 18. All right, so that is a spread is 1 to 18. So that's a pretty big spread. So we're going to have a larger standard deviation. Okay, if we look at this one, this is from 1 to 9. So our spread is 1 to 9, which is, we have nothing to compare it to, so we can't really say that the standard deviation is large, but it's going to be, an increased standard deviation than if it was smaller. All right, this one we have a spread that goes from 0 to 1. So this standard deviation is going to be pretty small. Okay, and here on this one, our spread is from 64 to 82. So again, that's what, 18? So that's going to probably lead to a large standard deviation. So let's take a look and let's interpret that information. All right, so change of data. We're going to look at this following data set, and we are going to say what happens if the data point 2 is decreased. How do these measures change? Okay, so that means we're going to take out 2, and instead of 2, it's going to be like 0 or 1. So we're going to leave it at 0, but everything else stays the same. Okay, so what's going to happen to the mean? Well, we have a smaller number in there, so smaller means our mean is going to decrease. Our median, we're not adding or removing any numbers. We're just changing one number, so our median is going to stay the same. Okay, so unless you change the amount of numbers in your set, the median is going to stay the same. When you change a value, your mean can either increase or decrease depending upon what that value is changed to. So now let's talk about the standard deviation and how that's going to change. So before, our spread was 2 to 20. Now, since we changed that, our spread is 0 to 20. So that means that our standard deviation, because our spread increased, our standard deviation is going to increase. Okay, so there's that. All right, now let's talk about now we're going to write our new data set. So it's going to just be 0, 4, 6, 8, 10, 12, 14, 16, 18, 20. Now let's look at the next one. If the data set point 20 is increased, how does this measure change? So again, we're still sticking with this one, and we're going to change the 20, and it's going to increase. So even if we just increase it to 22, let's answer these questions. Okay, so we got 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20, but we're going to change that 20. Let's just even change it to 22. So we increase the number, so that means that our mean is going to increase. Okay, because this number is now larger than the mean, our mean is going to increase. Again, the median, we're not adding any numbers into this set. We're just simply changing one, so it's going to stay the same. If I had maybe put in 24 in addition to changing, then our median would change, okay? But we're not doing that. We're just changing a number so our median stays, all right? And then our standard deviation, is that going to increase or decrease? Well, let's look at our spread. We went from 2 to 20, and now we're going from 2 to 22, so our spread increased, so our standard deviation also increases, okay? And we wrote the new number set up there. Let's talk about comparing and answering these questions. So, identify and compare the centers of the dot plots. Okay, so we're going to find the center. So we're going to count, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 16 divided by 2 is 8. So we're going to count off 8. 1, 2, 3, 4, 5, 6, 7, 8. So for A, for display A, our center is 78. Okay, let's talk about this one. This is going to be 16. Let's find out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So it's also 16, so we need to count off 8. So 1, 2, 3, 5, 6, 7, 8. Okay, so our display is also 78. So what do we know? The centers are equal. 78, 78. Okay, identify the shape. So let's look at display A. So we're going to draw on our line over here, and our tail is on the left, so it's not normal. Our tail is on the left, so it's left skewed. Okay, display B, well, it looks to be symmetrical right down the middle, so that is a normal distribution. And then 14, select the correct statement comparing the spread of the dot plots. So if we look at our data, the spread here for this one is 66 to 82. And for display B, the range is, or the spread is 72 to 86. So we're going to find the range of that. So 82 minus 66 is 16. Okay, and then 86 minus 72 is 14. Okay, so which of these has a larger spread? Display A does, so that means its standard deviation, the standard deviation of A is larger than the standard deviation of B. Okay, so display A is larger than display B. Okay, it's not smaller because the spread of A, wait, let's read these questions again, answers again. Display A standard deviation is larger because the spread is wider than display B. Yes, that is true. Okay, display A standard deviation is smaller because spread is wider than B. That's not true. Display A is larger, we know that, because the spread is closer. That's a false statement. And then display A is standard deviation is smaller because the spread is closer. The spread is not closer on A. Okay, so the standard display A standard deviation is larger because the spread is wider than display B. And that is true. We have 16 versus 14. Okay, so this one is going to have a larger standard deviation than display B.